Tonight, we'll take a slow trip into the distant past, far beyond human history, even beyond the age of dinosaurs. We re-go in to look at the 5 great times when life on Earth almost came to a complete stop. These weren't small setbacks or rough centuries. They were massive global disasters that changed the planet forever. But don't worry, we'll keep things peaceful and relaxing as we go. Now, a small warning. I hope this video relaxes you, not keeps you up. But if curiosity wins out, at least you'll leave knowing more about mass extinctions than when you arrived. Let's begin. We're heading back over 485 million years to the Ordovician period, long before dinosaurs or forests. At that time, dry land was mostly empty. The real action was in the oceans. Vast, shallow seas covered much of the planet, filled with life. Coral-like creatures built the first reefs. Brachiopods clung to rocks, filtering water for food. Trilobites, those famous hard-shelled creatures with many legs, scurried across the seafloor. Nautiloids, some as long as a small car, glided through the water using jets of motion. This period was a burst of evolution called the Great Ordovician Biodiversification Event, over just tens of millions of years. The number of marine species more than tripled. The seas were warm, full of nutrients and teeming with possibilities. The continents, mostly joined together in a southern supercontinent called Gondwana, were slowly moving across the globe. It was an alien but thriving world, and then suddenly it all collapsed. Earth experienced its first known mass extinction. It struck in 2 big waves, wiping out about 85% of all marine species. Coral reefs crumbled, trilobites disappeared in droves, and ecosystems that had flourished for millions of years were gone. So what happened? The leading cause was climate. Toward the end of the Ordovician, Earth fell into one of the most severe ice ages in history. Gondwana had drifted over the South Pole, where ice began to build up. Snow and glaciers reflected sunlight back into space, creating what scientists call the albedo effect. The more ice, the more cooling, setting off a self-reinforcing freeze. At the same time, levels of carbon dioxide in the air dropped. Fewer greenhouse gases meant less heat trapped in the atmosphere, which pushed global temperatures even lower. As glaciers grew, sea levels fell sharply. The shallow seas that had supported so much life dried up. Whole habitats disappeared almost overnight. Then came the second blow. After a period of deep cold, the glaciers melted, sea levels rose again, and ocean chemistry shifted. Oxygen dead zones spread across the seafloor, making survival even harder. Creatures already weakened by the cold couldn't withstand the new challenges. In the fossil record, we see the devastation clearly. Trilobites nearly wiped out, reef builders gone, and echinoderms, the ancestors of today's starfish, reduced to a handful of survivors. Recovery did come, but it took millions of years. The seas eventually refilled. Coral reefs tried again. And new forms of life, like jawed fish, appeared in the Silurian period that followed. But the Ordovician extinction was Earth's first great reset. It proved that the planet's shifting climate, drifting continents, and changing atmosphere alone without asteroids or supervolcanoes could wipe the slate clean. And yet it also showed that life endures. Some species clung on through the cold, others survived the warming seas, and from them, new ecosystems slowly grew. Extinction is devastating, but it also clears the way for transformation. When we look back, it's humbling. The thriving reefs of the Ordovician, the bustling trilobite trails, all silenced, not by predators or disease, but by Earth itself. The planet rewrote the rules, and life had no choice but to adapt. The deep ocean, which had always depended on steady mixing between surface and bottom waters, began to stagnate. Warm, oxygen-rich water no longer reached the depths, leaving the lower layers starved of oxygen. This process, called ocean anoxia, is as grim as it sounds. Marine animals need dissolved oxygen to survive, and without it, even the toughest species faltered. Vast regions of the seafloor became lifeless. The carbon cycle broke down, plankton declined, and with them, the very base of the food chain started to collapse. After nearly 1 million years of icy dominance, the climate suddenly shifted again. Glaciers melted, sea levels rose, but instead of restoring balance, the rapid change caused further chaos. Fresh meltwater disrupted ocean circulation, worsening oxygen loss in the deep. Nutrients washed into the seas, fueling algal blooms that consumed even more oxygen when they decayed. The planet swung from extreme cold to sudden warmth, leaving ecosystems with no time to adapt. The extinction struck in two waves. The first came with the freezing, when falling sea levels destroyed shallow marine habitats. The second hit during the warming phase, as the oceans turned chemically unstable. Each round of devastation left fewer survivors. Graptolites, once so common they're now used to date Ordovician rocks, nearly vanished. Brachiopods, once thriving filter feeders, collapsed to a fraction of their diversity. Trilobites suffered catastrophic losses, with many lineages disappearing forever, yet a few species, those able to tolerate a wide range of conditions, held on. These survivors would later rebuild ocean ecosystems. The Ordovician Silurian extinction is often overshadowed by the dinosaur-killing asteroid. But by raw numbers, it was one of the most severe events in Earth's history. More than 80% of marine species disappeared. And unlike later extinctions, this one had no asteroid or supervolcano to blame, just the slow but relentless forces of drifting continents, falling carbon dioxide, and shifting seas. It's a stark reminder that Earth doesn't always need drama to erase life. Quiet, steady changes in climate can be just as deadly, and yet life persisted. Graptolites, trilobites, and others barely survived, but survived nonetheless. As the climate stabilized, the Silurian period began around 443 million years ago. Glaciers retreated, seas refilled, and survivors spread into the newly opened habitats. These weren't glamorous creatures. They were tough, adaptable, and unpicky, but they endured, which was all that mattered. Brachiopods made a comeback. Crinoids, the feather-armed relatives of sea stars, returned. Trilobites stumbled onward, though their peak days were behind them. Graptolites, reduced to only a few lineages, slowly diversified again. Coral reefs also reappeared, built this time by tabulate and rugose corals. They added new structure to the seas, creating shelter for other creatures. Even the enormous sea scorpions, Eurypterids, prowled once again, some growing longer than 2 meters. The Silurian wasn't just recovery, it was innovation. Extinction had cleared the stage, leaving empty ecological roles. Evolution filled them with experiments. Most important was the arrival of the first jawed fish. Earlier fish had no jaws, feeding by filtering or scraping, but with jaws came grasping, biting, and chewing, true predation. Heavily armored placoderms were the tanks of the ancient seas, while smaller acanthodians, or spiny sharks, hinted at what would one day evolve into modern fish, sharks, and rays. Life also began creeping onto land. Tiny plants like Cooksonia appeared along damp shorelines. They had no roots, leaves, or flowers, but they had vascular tissue, allowing them to grow taller and survive drier conditions than algae. These early plants stabilized soils, influenced weathering, and even began altering carbon dioxide levels. They were the first faint brushstrokes of green on an otherwise barren landscape. This pattern extinction, followed by bursts of creativity, shows up again and again in Earth's history. When ecosystems collapse, opportunities open. Survivors adapt, explore, and sometimes reinvent what life can look like. The Silurian recovery wasn't fast, and some groups never regained their former glory. But overall, the biosphere proved astonishingly resilient. The lesson is simple. Extinction clears the board, and evolution redraws the game. Earth's first great extinction wasn't the end. It was a turning point. The seas of the Silurian carried scars of loss, but also the seeds of the future. Coral reefs rebuilt. Fish with jaws began their reign, and plants prepared to conquer land. By the Devonian period, around 419 million years ago, the stage was set for something even more remarkable. Forests rising, fish diversifying, and life daring to leave the oceans for good. Beneath the rapid growth and innovation of life during the Devonian, a slow-moving disaster was taking shape. Unlike sudden catastrophes caused by asteroids or eruptions, this extinction stretched across nearly 20 million years. It didn't happen all at once, but in a series of extinction pulses. Life would crash, recover slightly, and then collapse again. At least 5 major pulses have been identified, each affecting different groups of organisms. The exact causes are still debated, but one leading suspect is the rise of forests. As plants grew deeper roots, they broke down rock and pulled carbon dioxide from the air. Over time, this cooled the planet. Meanwhile, heavy rains washed nutrients from soils into rivers and seas. This triggered huge algae blooms that consumed oxygen as they decayed, creating large dead zones in the oceans. Marine habitats became unlivable, especially for reefs. Once thriving reef systems collapsed and didn't return on a similar scale for another 100 million years. Fish also suffered. Placoderms, the heavily armored predators of the Devonian, disappeared. Lobe-finned fish and early tetrapods lost ground too, especially in shallow coastal waters where temperature, oxygen, and salinity constantly shifted. The result was a sharp drop in biodiversity and ecosystems stripped down to simpler forms. Still, some creatures survived. Small, flexible species that could tolerate low oxygen and unstable conditions managed to hang on. Among them were early amphibian ancestors living in freshwater margins and hardy arthropods feeding on organic debris. These survivors carried the potential for the next wave of evolutionary change. Forests, though partly responsible for the crisis, also reshaped the future. Trees like Archaeopteris grew over 20 meters tall, creating the first real forests. Their roots sped up weathering, cooled the planet, and changed the chemistry of rivers and oceans. While devastating to reefs and marine life, forests opened the door for new opportunities on land. Insects, tetrapods, and more diverse plants followed. The extinction pulses also cleared space for new kinds of fish. The placoderms vanished, but lighter, more adaptable ray-finned fish took their place. Unlike their bulky predecessors, they were quick, versatile, and able to survive shifting conditions. Over time, these modest survivors became the most diverse group of vertebrates on Earth. Meanwhile, lobe-finned fish held on to something extraordinary: the bones in their fins. Those bones would eventually evolve into limbs. From these survivors came the first true steps onto land. The Devonian extinction was not a sudden catastrophe, but a long, suffocating decline. Yet from it emerged forests, amphibians, and the ancestors of nearly every land vertebrate alive today. It was a slow collapse, but also a turning point, proving that even in times of loss, life adapts and reinvents itself. Beneath the Devonian's burst of growth and innovation, a slow-motion crisis was unfolding. This was the kind of sudden disaster you'd expect from an asteroid strike or a massive eruption. Instead, it played out over nearly 20 million years. The Devonian extinction came in waves, what scientists call pulse extinctions. Life would collapse, then briefly recover, only to be struck down again. At least 5 major pulses are recognized, each one taking a toll on different groups of organisms. The causes are still being pieced together, but one leading suspect was the rise of forests. These new trees weren't just silent additions to the landscape, they transformed the planet. Their roots dug deep into rocks, speeding up chemical weathering. This process pulled carbon dioxide from the air, cooling the earth over time. At the same time, heavy rains washed nutrients from soils into rivers and seas. That nutrient flood triggered massive algae blooms. When the blooms died off, oxygen in the water plummeted, leaving behind vast dead zones. Marine life suffered the most. Reef systems, once flourishing, collapsed and wouldn't return on a similar scale for another 100 million years. Placoderms, the armored fish that had dominated the seas, vanished. Lobe-finned fish and early tetrapods also declined, especially in the unstable shallow waters where oxygen, salinity, and temperature fluctuated wildly. Biodiversity dropped sharply. Entire ecosystems unraveled. But some creatures endured. Small, generalist species, those able to tolerate low oxygen and unstable environments, managed to survive. Among them were the ancestors of amphibians clinging to life in freshwater margins, and arthropods scavenging on land and sea. Forests, though partly responsible for the crisis, also set the stage for the future. Early trees like Archaeopteris rose over 20 meters high, creating the world's first real forests. Their roots reshaped soils, rivers, and oceans, altering climate and chemistry on a global scale. While devastating to marine life, These forests opened the door to new opportunities on land. Insects spread, plants diversified, and tetrapods inched closer to becoming true land dwellers. The extinction pulses also cleared space in the seas. Placoderms were gone, but their disappearance allowed other fish to thrive. Ray-finned fish, lighter and more adaptable, took over. At first, they were small and unremarkable, but over time they became the most diverse vertebrate group on the planet. Meanwhile, lobe-finned fish hung on. Unlike their ray-finned cousins, they carried something unique: bones in their fins. Those bones were the foundation of limbs. From them would come the first creatures able to walk on land. The Devonian extinction didn't end with a bang. It was a long, drawn-out collapse, more like a slow illness than a sudden blow. Yet within that decline were the seeds of something new. Forests spread across the continents. Amphibians emerged at the water's edge. And evolution, even through loss, found a way forward. The Devonian, often called the Age of Fishes. Oceans swarmed with armored placoderms, coiling ammonites, and early sharks. Forests spread across the continents, changing the planet forever. It was a time of growth, of innovation. But beneath this golden age, something darker stirred. The crisis unfolded slowly. Not in days, not in years, but across nearly 20 million years. The extinction came in waves, 5 great pulses, each one striking down life, leaving only fragments behind. The causes? Still debated. But one suspect looms large: the rise of forests. Trees like Archaeopteris grew tall, their roots cracking stone, drawing carbon dioxide from the air. The earth cooled. Heavy rains washed nutrients from the land into rivers and seas. Algae bloomed in massive swarms. When those blooms died, they drained oxygen from the oceans. The seas began to suffocate. Reef systems, once thriving, collapsed. It would not return for another 100 million years. Placoderms, the great armored fish of the Devonian, vanished. Lobe-finned fish, ancestors of future tetrapods, suffered heavy losses. Shallow waters, once nurseries of life, became unstable. Oxygen dropped, temperatures shifted, salinity wavered. Life struggled to keep up, yet some survived. Small, adaptable species, creatures that could handle low oxygen and harsh conditions. Among them arthropods, scavenging along coasts, early amphibians clinging to freshwater margins. Forests, though part of the problem, also shaped the future. They remade soils, changed rivers, altered the air itself. While reefs collapsed at sea, life on land seized new ground. Insects spread, plants diversified. Tetrapods crept closer to taking their first true steps on land. In the oceans, the extinction cleared the stage. The mighty placoderms were gone. In their place, lighter, more adaptable, ray-finned fish rose. At first small and ordinary, but in time they would become the most diverse vertebrates on Earth, and lobe-finned fish. They held on to something extraordinary: bones in their fins, the blueprint of arms and legs. From them would come the first creatures to walk the earth. The late Devonian extinction was no sudden blow. It was a long unraveling, the planet slowly shifting beneath the weight of its own changes. But even in collapse, life found a way forward. Forests took root, amphibians emerged. And evolution's slow, relentless turn loss into opportunity. For millions of years, early mammals lived in the shadows, literally. They avoided larger animals by being mostly active at night, yet this lifestyle helped them survive. While dinosaurs filled the daylight world, mammals carved out a smaller but steady role in the underbrush. Their tiny size made hiding easy, their warm-blooded bodies helped control temperature, and their fur kept them warm in cooler climates. They weren't evolutionary mistakes, they were survivors, waiting their turn. Meanwhile, dinosaurs were thriving in the daylight. Their success wasn't just about size or appearance. With fewer rivals around, evolution had room to experiment. Necks stretched longer, claws changed into wings, beaks replaced teeth, and some developed hollow bones while others grew heavy armor.
Ow.
Dinosaur species branched into hundreds of forms, many we are still discovering. But their rise wasn't guaranteed. It was chance, adaptability, and the elimination of competitors that gave them dominance. The mass extinction at the end of the Triassic cleared the stage, and dinosaurs happened to be the winners. Had that volcanic activity never happened, other reptiles called pseudotsuchians might have stayed in control, and dinosaurs may have remained minor players. But the Earth shifted, climates changed, and dinosaurs stepped into power. Their reign would last more than 130 million years, spreading across every continent and environment, from icy forests to tropical swamps. They weren't only big, they were versatile, clever, and sometimes even social. As the Triassic gave way to the Jurassic around 200 million years ago, Earth began to calm after ages of chaos. The supercontinent Pangaea was still splitting apart, but volcanic eruptions slowed, and the climate became more stable. Rainfall increased, temperatures leveled, and life flourished. Huge fern fields and conifer forests spread, creating endless food for plant-eating giants. The sauropods, massive long-necked dinosaurs, soon ruled the land. Diplodocus stretched over 25 meters long, while Brachiosaurus reached high into treetops. They moved in herds, shaping the land with every step. Their huge size was possible thanks to fast growth, efficient lungs, and warm climates with little competition. But predators like Allosaurus kept them in check. These agile hunters, though not as famous as T-Rex, were powerful Jurassic carnivores, and the oceans were no less dramatic. Ichthyosaurs swam like reptilian dolphins, some small and quick, others massive. Plesiosaurs cruised with long necks and sharp teeth, snatching fish with stealth. Ammonites filled the seas again, sharks diversified, and early coral reefs supported lively ecosystems. Above the land, pterosaurs began to master the skies. Some were small and nimble, while others would one day grow to airplane-sized wingspans. And in the background, tiny mammals endured still nocturnal, still living on insects and seeds, but slowly testing traits like fur, warm-bloodedness, and parental care. The Jurassic world was balanced but dynamic. High carbon dioxide kept the climate warm and humid. Shallow seas provided rich habitats, and rain allowed dense vegetation to spread. Life thrived at every scale. Herds of sauropods shook the plains. Early birds filled the air with calls, reefs glowed with marine activity, and pterosaurs soared overhead. Dinosaurs didn't inherit this world icily. They seized it after extinction, and then filled every role nature allowed. But eventually, even they faced disaster. By the late Cretaceous, dinosaurs still dominated. Triceratops grazed in herds, raptors hunted, and pterosaurs glided above. The seas held mosasaurs, ammonites, and coral reefs. Life seemed busy and full. Then, about 66 million years ago, everything changed in an instant. A rock about 10 kilometers wide slammed into what is now Mexico's peninsula at nearly 20 kilometers per second, more than 70,000 kilometers per hour, known as the Chicxulub impactor. It unleashed energy equal to over 100 million megatons of TN, T billions of times stronger than the Hiroshima bomb. The impact created a crater over 180 kilometers wide, triggered global earthquakes, and launched debris into space. As fiery fragments rained back down, the atmosphere heated like an oven, igniting wildfires worldwide. Tsunamis hundreds of meters high swept across coastlines. Forests burned, animals died, and marine life was thrown into chaos. But the worst came after. A long, dark impact winter. Dust, ash, and sulfur blocked sunlight, halting photosynthesis. Plants and plankton died, food chains collapsed, herbivores starved, and predators followed. Within months, the mighty dinosaurs were gone. The only ones to survive were small, adaptable creatures. Crocodiles endured by living in water and hibernating. Turtles, insects, some mammals, and a group of feathered dinosaurs, the ancestors of modern birds, pulled through. From those survivors came the robins, eagles, and hummingbirds we know today. The age of dinosaurs ended in fire and shadow, but their story never truly disappeared. Their descendants still live among us, carrying the legacy of giants who once ruled the earth. The Cretaceous-Paleogene extinction, often called the KPG event, was not just the end of the dinosaurs. It was a turning point in Earth's story. For over 150 million years, dinosaurs had dominated the land. But in one catastrophic moment, their age ended, and the stage opened for mammals. Suddenly, entire ecosystems were empty, and the survivors evolved quickly, spreading into roles that would reshape the planet. Scientists mark this boundary in the rock record with a thin clay layer, enriched with iridium rare on Earth, but common in asteroids. This layer has been found across the globe, from Denmark to North America to the Pacific seafloor. It's like Earth left a note saying, "This event mattered." The asteroid impact that created the Chicxulub crater was devastating. Had it missed by only a few hours, it might have plunged into the ocean, sparing the dinosaurs. Instead, it struck land, unleashing firestorms, tsunamis, and shockwaves that shook the planet. But the real killer came after. The blast filled the skies with dust, ash, and sulfur. Sunlight dimmed, plunging the Earth into a cold, dark twilight. Photosynthesis collapsed for months, maybe years. Plants withered, forests died, and ocean plankton at the base of the food chain disappeared. Herbivores starved first, then carnivores. Coral reefs crumbled, and marine food webs unraveled. This extinction wasn't just one fiery moment, it was a long, brutal breakdown of Earth's systems. But in that chaos, small survivors endured. Mammals had already been around for tens of millions of years, mostly tiny, nocturnal creatures hiding from dinosaurs. Their small size, flexible diets, and ability to dig or hide in crevices gave them an edge. Some could hibernate or go into torpor, conserving energy until food returned. Being warm-blooded also helped them stay active in the sudden cold. Birds, too, made it through. Technically, they are dinosaurs, the only branch that survived. Not all birds lived, though. Large, specialized species perished. The survivors were small, adaptable ground dwellers, some able to eat seeds that lasted long after plants died. From those hardy species came the thousands of bird varieties we know today, from sparrows to penguins. Oh, the oceans also reset. Marine reptiles were gone, plankton had collapsed, and reefs took millions of years to recover. But sharks, rays, and some bony fish survived, as did many deep-sea creatures shielded from surface chaos. On land, plants took a new direction. With conifers and ferns reduced, flowering plants' angiosperms expanded dramatically. Grasses, fruit-bearing shrubs, and blossoming trees spread across the continents. These new habitats fueled the rise of mammals, and rise they did. With dinosaurs gone, mammals diversified quickly. Some became tree dwellers, leading to the first primates. Others spread into open plains, adapting to grazing. Whales eventually returned to the sea, bats to the skies, while elephants, cats, dogs, and rodents all began their long evolutionary journeys. Their warm-blooded bodies, live births, and bigger brains gave them an advantage in this new world. From these survivors, humans would eventually appear, descendants of primates that emerged tens of millions of years after the asteroid struck. Our very existence is tied to that disaster 66 million years ago. Without it, dinosaurs might still rule, and mammals might never have risen beyond the shadows. The KPG extinction was destruction, but it also cleared the way for renewal. Birds carry the legacy of the dinosaurs. Mammals filled the empty roles. And over millions of years, the world transformed into the one we know today. Out of fire and darkness came resilience, adaptation, and a very different future. Each great extinction tore ecosystems apart and forced life to begin again with fewer options. Every time, the survivors, often small, overlooked species, went on to shape a new age. Without the Ordovician-Silurian extinction, vertebrates may never have gained the variety needed to leave the seas. Without the Devonian crisis, early tetrapods might not have crawled from the swamps. Without the enormous die-off at the end of the Permian, archosaurs, the ancestors of dinosaurs and crocodiles, might never have had their chance. Without the Triassic-Jurassic turnover, dinosaurs might have stayed small, obscure reptiles instead of dominating the planet for over 150 million years. And without that asteroid 66 million years ago, dinosaurs would still rule, while mammals might still be hiding in the underbrush. No moon landings, no Renaissance, no coffee, no jazz, no internet, and no bedtime talks about the 5 times the world nearly ended. It may feel strange that the end of one world makes way for another, but that's how nature works. Extinction is not only destruction, it clears the stage for something new. Painful? Yes. Brutal. Without question. Yet also creative, Life doesn't grieve the lost. It rebuilds from what's left. Today's ecosystems, the coral reefs, the tundra, the grasslands, the rainforests still carry marks of past disasters. Even now, we share the planet with echoes of history. Horseshoe crabs still crawl in the surf, nearly unchanged for hundreds of millions of years. Ginkgo trees spread their fan-shaped leaves, once shading Jurassic giants. And inside our DNA, there are traces of ancestors that clung to survival in the shadows. But extinction isn't just a tale from deep time. Today's species are vanishing again, driven not by asteroids or volcanoes, but by us. Habitat loss, climate change, pollution, and overuse are pushing biodiversity toward what many scientists call a sixth mass extinction. Unlike ammonites, trilobites, or mammoths, though, we can see it happening, and we can still decide what to do. The fossil record is more than a list of losses. It's a guidebook to resilience, shows how life returns, how diversity recovers, and how small, adaptable survivors sometimes shape entire futures. With that knowledge, we can choose to preserve more of what we have, instead of letting it vanish. Think of it this way: the forests you've walked through, animals you've seen, even your own life, none of it exists in spite of catastrophe, but because of it. Extinctions arrive suddenly, sometimes a slow suffocation. Sometimes a violent impact, and after them, the Earth is never the same. We've followed 5 of these events: the icy Ordovician Silurian that drained seas of oxygen, the drawn out; Devonian losses tied to the rise of forests; the Permian Triassic disaster that nearly sterilized the Triassic-Jurassic turnover that opened the door for dinosaurs; and the Chicxulub impact, 66 million years ago, that cleared the way for mammals and eventually for us. The numbers are staggering. 90% of marine species lost here. 70% of vertebrates gone there. Whole clades erased. But this isn't only a story of endings. Each collapse sparked new beginnings. Out of them came jawed fish, land-walking tetrapods, flowering plants, birds, mammals, whales, and primates. When life is pushed to the edge, it often becomes inventive. Now, though the story has changed, we are no longer bystanders in Earth's experiment. We are active participants, and our choices matter. Forests are shrinking. Reefs are bleaching. The climate is shifting at a speed not seen in millions of years. But unlike past victims of extinction, we understand what's happening. And because we understand, we can choose differently. The fossil record reminds us that no species lasts forever, not even Tyrannosaurus. Yet it also shows that life is resilient. Microbes return from the deep. Ferns sprout from ash. Small mammals crawl from burrows into a changed world. The spark of life always comes back. And tonight, as you rest, think of that. The stars above have witnessed it: asteroids falling, continents drifting, forests blooming, glaciers carving mountains. Now they watch us, a species of stardust that can think, remember, and choose. We can still decide to protect what remains, to reduce the damage, and to leave a richer world behind. Sleep well, and remember this: you are here because life endured 5 global resets. Against all odds, it carried on. And even in the darkest times, it found a way forward.